Allow me to remind you a few rules that the presenters must follow. The presenter is given 10 minutes to present the research paper. The first bell will ring as soon as the presenter begins their presentation. The second bell will ring 2 times to indicate the presenter has 2 minutes left to finish the presentation. The third bell will ring 3 times to indicate the end of the presentation session. After all the presentation ends, the Q&A session will begin immediately. The allocated time given is 15 minutes and the bell will ring 2 times to indicate the end of the Q&A session. For online attendees, you may submit your question in a Q&A tab. All presenters must adhere to the time set and are kindly requested to be aware of your turns of presentation to ensure the smoothness of the presentation session. All presenters are required to remain seated in the presentation room until the end of the session as a sign of respect to the other presenters. Without further ado, let us welcome the moderator that will be conducting the second session, Harnessing Modernization for Next Generation Statistical Analysis, yang berusaha, Madam Zima Masfahani Mazlan, Deputy Director of Data Management and Statistics, Bank Negara Malaysia. Please welcome.
Hello, everyone. So basically, I'm just trying to break the ice because I know that the presenters are a bit nervous. So I'm just telling you that I am nervous as well, although I'm just a moderator. So first of all, I would like to welcome everyone to this session. The session titled Harnessing Modernization for Next Generation Statistical Analysis. So basically, we will have 3 esteemed guests who will then be sharing their presentations. Each of the presenter will be given 10 minutes for them to present their presentation. And for the time management purposes, we will let all the presenters to complete their presentations. Before then, we'll open the Q&A for to the floor. First of all, I would like to remind everyone to silence your phone so that the presenters can present their papers smoothly. And without further ado, I would like to invite Professor Hafsah Midi, who will presenting a paper titled An Efficient Method of Identification of Outliers for High Dimensional. Prof. Hafsah is a professor at the Institute for Mathematical Research, University Putra Malaysia. She has published more than 10 papers in citation index journals. Her research interests, among others, focus machine learning, pattern recognition, computational statistics, statistical modeling for low and high dimensional data. Professor Hafsah is also currently the president of Malaysia Institute of Statistics. I would like to invite Prof. Hafsah to begin her presentation. The floor is yours, Prof.
Thank you, Madam Chairman. Assalamualaikum warahmatullahi wabarakatuh, and good afternoon. All right, this is the title of my talk, An Efficient Methods of Identification of Outliers for High Dimensional Data for Making Accurate Statistical Inferences. Ini tak jalan lah. Okay, I just want to ask you, have you ever encountered a problem when you want to analyze the data using multiple linear regression? You cannot obtain the parameter estimate, and you cannot estimate or predict the Y variable based on the response variable, based on the independent variable. Why you cannot obtain the parameter estimate? Because of the X transpose X metric is invertible. Yeah? You cannot get their inverse value. Yeah? Why this happen? This situation usually occurs in high dimensional data. Yeah, where high dimensional data refers to a situation when the number of predictor variables is much larger than the sample size n. Yeah. So example of high dimensional data in gene analysis, millions of genes are measured for a single individual. Yeah. And tens of thousands of gene expression values available in tumor classification using genomes data. Image analysis contain thousands of resolution images in which where a small number of samples and many more. Yeah. So meaning that you have to keep in mind that high dimensional data where the number of predictor values, predictor variable is much larger than the sample size n. The detection of high leverage point. What is high leverage point? Outlying observation in the X direction. Yeah, it's very crucial. For example, in microarray data analysis to spot a malignant tumor in an MRI scan. Yeah, and classifying fraud detection in credit card transaction. Challenge. The challenge in analyzing high dimensional data. The metrics that I mentioned earlier related to some algorithm may become singular. Yeah. So by the existing classical methods based on the Mahalanobis distance is not applicable in high dimensional data since the probability is not invertible. Not many works have focused on the detection of high leverage point for high dimensional data, but some of me and my students have already published a few methods in detecting high leverage point for high dimensional data. Hubert et al. Proposed the use of robust principal component analysis to diagnose bad and good leverage point in high dimensional data. However, we discovered that the ROB PCA procedure does not perform well for outliers less than 30%. Bouch et al. Developed the minimum regularized covariance determinant technique to obtain the mean and covariance metric for high dimensional data and use it to compute robust Mahalanobis distance to detect outliers, and we will call it a high leverage point. Yeah? The method is very successful for the detection of high leverage point for high dimensional data. However, through our investigation shows that the performance of RMD, MRCD failed to correctly detect high leverage point when the dimension is more than 700. Zaharia and me, we published this already, developed a method of detecting high leverage point. So the MRCD PCA is very successful in the detection of high leverage point with small swamping effect. The only shortcoming, just a little bit of shortcoming of this method is that its algorithm is quite cumbersome and takes long, not so long computer, a little bit computers, a little bit longer computational running time. Hence, it is very important to establish an alternative reliable methods of identification of high leverage point in high dimensional data by integrating the minimum regularized covariance determinant in its establishment. So the objective of this presentation is to develop a reliable methods of identification of high leverage point in high dimensional data denoted by IRPCA, and to show that this developed method is more reliable than the existing methods and to apply the methods to real data sets. Now, so actually, in robust Mahalanobis distance, where some researchers try to identify high leverage point, have to use a location and covariance matrix in the formula of robust Mahalanobis distance. And the location and the covariance matrix usually using minimum covariance determinant, in short, MCD. The problem with the MCD is that it cannot be applied to data with high dimensional. Yeah. So in this situation, an improvement to the MCD is needed to make it work for high dimensional data. So we will make use of this MRCD in the formulation of our proposed methods of identification of high leverage point. All right, so well, this is very long to mention, yeah. So I just want to mention this is the formula to to obtain the minimum regulus covariant determinant, where using this method, we will obtain the location and the covariant matrix. Now our robust principal component. This robust principal component is widely used to detect high leverage point in high dimensional data. However, this I already mentioned earlier that this ROP-PCA has a problem, whereby it has a swamping effect. Yeah. What is swamping effect? Swamping effect is when inliers is declared as outliers. So that is not good. Yeah. So we want to develop a method where we have 100% of successful of detection of high leverage point with very low masking and swamping effect. Right? Yeah. So this is the methods is a combination. So this is a method that we already published. Yeah. In the Journal of Applied Statistics last year. The method is the combination of MRCD and PCA. The high dimension. This method is quite complicated, where first you have to reduce the number of dimension from P, very large P, into smaller component using principal component analysis. Then from the low dimensional data, we reconstruct back, we transform back to the original data matrix. Yeah. Another 5 minutes, is it? Another 5 minutes, yeah. So, well, just want to mention that this method is good, but has a problem. Yeah, I mean, longer computational time. So what we now we want to develop another method, better method. First, what we need to do, this our method here. First, for each observation, we center the data by subtracting the median of each column. Then we apply the principal component analysis to center the data to reduce the number of original P variable into K-dimensional subspace, where K is much less than the P. So the number or dimension of K return is based on the script plot or the cumulative variant, in which the first K loading is at least 80%. Yeah. And then we project the data points on the K-dimensional subspace and obtain the principal component score, where the score are the entries of N by K matrix. Yeah. So then step 4, after we get this matrix, we estimate the robust scatter matrix of the principal component using the MRCD, the minimum regular covariant determinant, to estimate the location and the covariant matrix. After that, then we compute the robust Mahalanobis distance for each observation using this formula, where the mean, if you look at that, the mean and the covariant matrix based on the minimum regular covariant matrix, yeah, after the matrix has been reduced to K-dimensional, right? So then, yeah, following whatever we have done before, we propose a cutoff point, yeah, to know. So now, yeah, just want to show you. We want to show a simulation study to show that our method is much better. I mean, better than the existing method. Where if you look at this here, yeah. So this is our new method. Yeah. Well, here this is our method also published. Yeah. So this is the ROP-PCA. This is the existing method, and this is percentage of masking, swamping. If you look at this, we generated a 5 outlier P, very large P, and the N is 50. Yeah, and we look at this. All methods have 100% of detection, correct detection of outliers. Masking effect also small. I mean, no masking effect. But the swamping effect, if you look at this, the existing method has a swamping problem. Yeah. But this our method. We just want to improve our methods already published. So we get this almost similar. The only difference is that our previous method is much longer. I mean, not much longer. the time taken is longer than our method, and also that method has some not problem, but has cumbersome. I mean, like you have to transform back to the original, transform back here and there, and takes time. Yeah. So then, well, we also try for n equal to 100, and p is still large. And we also try n equal to 100 and p make it larger and so on. Yeah. And still our methods here shows a good method here. Yeah. Where the what we call this the swamping effect is small, and this rock PCA is large. Yeah. And this is for simulation study, but we also apply to our data. Well, if you look at this is the running time. Yeah, the running time for the simulation study, where you can see that this our method, yeah, and has a smaller running time compared to the existing method. Yeah, all right. So here the running time is well, just going to show this, and now we apply to the octane data set. Yeah. So this data set has 226 wavelength and 39 gasoline sample. So this is high dimensional data where P is much larger than the sample size N. Yeah. So here, this data set has already declared to have 6 sample, 6 high leverage point. This observation are the high leverage point. So now we want to show that our method can detect this observation as high leverage point. Right? So now we look at this and we apply our data here. You can see that our proposed method can detect 100%. All those 6 observations as high leverage point, 100%. Yeah. And the running time 6.8. And this is our previous method. Yeah, this is our previous method. Also can detect 100%, successfully detect 100%. Also the same number of high leverage point detected, 100%. Yeah. And the running time, if you look at the running time, is much longer. Yeah. All right. So look what happened to the existing method. Yeah. The existing method 100%, but there are swamping. Yeah. Swamping observation have some swamping. Yes. It is consistent with the simulation study where there is a high level swamping effect. Yeah. And we also apply this data. This method to a real data. This data was collected from pediatric subject attending special clinic, Himalaya, yeah? And we want to know, yeah, how many high leverage point exist in this data set. So we apply our methods. Yeah, we apply our methods here. You can see that observation 1426 is declared as high leverage point. Yeah, because this and the running time is this much. And this is our proposed method. This is our previous proposed method. Also detect the same number of high leverage point. Yeah, but the running time is much. Not much longer. It's just a little bit longer than the previous. Our existing method. And if you look at this, the rock PCA, the existing method, has more, detect more high leverage point, where of course there are many swamping effects. Yeah, you have because you declare more than what is supposed to be. Only 2 actually, and the running time is also not so high, but it's very unsuccessful in detecting high leverage point. All right. So, well, of course, we have also applied to many data sets, and our methods is very successful in detecting the high leverage point. Right. So the conclusion, the IRPCA, that is our methods here, demonstrate outstanding performance, able to detect all high leverage point in high dimension data with a very fast computing time. Yeah. The existing method here successfully identify high leverage point, but longer running time, while raw PCA suffers from severe swamping effect problem. Yeah? The Monte Carlo simulation and real data set validated that our proposed method successfully detect high leverage point with 0 masking effect, but with a very small swamping effect for high dimension data with various sample size and number of independent variables. With that, thank you for listening.
Thank you, Prof. Hafsah. So we will proceed to our second presenter, Professor. We will have the Q&A after all the presentations. Okay, so our second presenter is Ms. So Sinzu. She will be presenting her papers on econometric analysis of stock market movements with macroeconomic changes in the US, a two-stage least squares approach. Ms. Sinzu is a third-year statistics student at the University Tun Hussein On, Malaysia, who has strong interest in data analysis, statistical modeling, and programming. Sinzu, the floor is yours.
Thank you, Mr. Zima. Good afternoon, everyone. Good afternoon, everyone. I'm honored to be here. My name is So Sinzu, and the title of my presentation is Econometric Analysis of Stock Market Movement with Macroeconomic Change in the United States by using the two-stage least square approach. Let me introduce to the topic. Financial market, especially stock markets, play a key role in the global economy, and stock market movement refer to the fluctuation in the stock price over time. Various macroeconomic indicators such as inflation, GDP, oil price, US Treasury yields can introduce endogeneity issue in the economic analysis. This factor help investor, policymaker, and economists predict trends and make informed decisions. There are two objectives of my study. The first one is to identify the correlation between the dependent variable and independent variable to determine the appropriate instrumental variable using correlation matrix plot. The second objective is to resolve the endogeneity issue using two-stage least square approach. For the methodology part, here is the flowchart of the process. First, we start the process with data processing. The data set is obtained from platform Kaggle, and the dependent variable is stock price index. The independent variable is inflation, oil price, GDP percent, unemployment rate, manufacturing output, and the trade balance and US Treasury. And the data cleaning include removing missing value and handling outlier to ensure a clean data set. Then the second step is check for the multicollinearity using the variance inflation factor VIF. Then continue by the Pearson correlation coefficient is visualized by using the correlation matrix plot. The third step is instrumental variable selection. Based on the analysis, US Treasury yields are selected as the instrumental variable. The second step is the statistical test and data visualization are used to confirm the relevance and exogeneity of the instrumental variable, then continue by the ordinary least square regression to establish the baseline result. The last step is the two-stage least square TSLS. This method includes the first stage and second stage. For the result part, the table shown all the VIF value of the independent variable. We can see that the VIF value for all the independent variables are less than 10, and indicating that there are no multicollinearity issue and all variables are remain to the second step of the process. From the result of Pearson correlation coefficient, we can see that the inflation rate was chosen as endogenous variables because it has the stronger negative correlation with stock index price with the value negative 0.79. and US Treasury yields were selected as the instrumental variable because they correlated with the inflation rate but minimally correlated with the stock index price. For the relevance and exogeneity test, the first output showed the strong correlation between the US Treasury and the inflation rate, so the relevance is confirmed. While the second output showed the US Treasury yields does not directly influence the stock index price. Relevance refers to the strength of the relationship between the instrumental variable and the endogenous explanatory variable in a regression model. Then the exogeneity refers to the instrument being uncorrelated with the error term in the regression model. And for the second output, US Treasury does not directly influence the stock price index, but it only through its influence on the inflation rate. This confirms the exogeneity. As a result, we can conclude that the relevance and exogeneity are conformed. Then continue by the process of ordinary square equation. The OLS model showed that when 1 unit of the inflation rate increase, the stock price index will decrease by 0.04676 units. And the p-value of variable inflation rate is less than 0.05, which means that the variable is statistically significant in the model. The last step is end with the two-stage least square. And for the first stage equation, the coefficient of US Treasury indicate that 1 unit increase in the US Treasury result in an average increase of 0.308621 unit in the inflation rate. Both intercept term and the coefficient for the US Treasury have p-value less than 0.05, so they are significant. For the second stage equation, the coefficient for the inflation rate indicate that 1 unit increase in the inflation rate leads to a decrease of 246,723 units in the stock price index, while considering the instrument variable. So both the intercept term and the coefficient for the inflation rate has p-value less than 0.05, so they are also significant. For the discussions and conclusion, there were no missing data and inflation observation after data cleaning. US Treasury as a potential instrumental variable due to its significant correlation with inflation rate. So further investigation into policy implication of using instrumental variables, such as the US Treasury in the economic forecasting and decision-making process, could guide effective policy intervention and economic management strategy. So these are the reference that I'm using in my scientific paper. And at the end, I also want to thank to my Dr. Kunesh, for providing me the guidance and reviewing for my paper. So that's all for my presentation. Thank you.
Thank you, Ms. Sinzu. I would like now invite our last speaker, presenter, Ms. Nur Hamizah Muhammad Sani from the University Pendidikan Sultan Idris, who will present her paper entitled Rainfall Prediction Using Hybrid Bayesian Method and Statistical Downscaling Based Machine Learning in Selangor. Hamizah, your floor is yours.
Thank you, moderator. Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Hamita binti Sani from University Pendidikan. Here, I would like to present my paper, which is rainfall prediction using hybrid Bayesian method and statistical downscaling based machine learning in Selangor. As we know, rainfall is vital for human life and civilization, influencing various sectors and agriculture and infrastructure. So, reliable rainfall prediction models are essential to improve disaster preparedness by providing early warnings for extreme weather events. However, handling large high-dimensional atmospheric data requires dimensionality reduction to simplify model training without losing predictive accuracy. Combining Bayesian method with machine learning improve not just high-dimensional data, but also addressing non-linearity and excess zeros in the data. Thus, we propose a prediction modeling, a hybrid machine learning based statistical downscaling, and Bayesian method, which is potentially advancing predictive accuracy and reliability for better decision making in agriculture, water management, and disaster preparedness. For methodology, for data overview, we use data from 33 rainfall stations in Selangor, spanning from 2008 to 2018, which is 10 years. So daily rainfall data will be as predicted, and atmospheric variable will be predicted. For methods, we apply three methods, which is PCA, which is we use to standardize the data and reduce the dimensionality of the data. Next, for non-homogeneous Markov model, this is one of the Bayesian method that can capture zero inflated data patterns. And next is random forest. This one of the machine learning techniques that can handle non-linearity in data and improve prediction accuracy. This is my framework of the study. So first, as we can see, for stage one, pre-processing for Y variable atmospheric data. After we standardize the data, we apply PCA to reduce the dimensionality by extracting the number of principal components without losing any significant information. So the analysis include the eigenvalues, variation, and cumulative percentage. So this substantial reduction in dimensionality resulted in the formation of a new dataset for the next. And for Y variable, we apply non-homogeneous Markov model to capture the zero inflated data, and the application of the NHMM reveal a well-defined symmetric distribution, resemble a bell curve. For the stage two, we apply random forest utilizing 5 decision trees to forecast rainfall trends in Selangor. The dataset will be divided into two sections with 70% of the data used for the calibration phase and the remaining 30% for validation purpose. And the proposed model performance was evaluated using metrics such as root mean square error, dash Sutcliffe efficiency, mean absolute error, and mean forecast error for both the calibration and validation periods. This is the scatter plot. The scatter plot shows predicted rainfall values against their index. It reveals a tendency for predictions to cluster around consistent values for some variability. And next, the table shows the performance value of the proposed model. So we can see that RMSE and MAE indicate moderate prediction accuracy, and SE demonstrate decent predictive capability, and MFE suggests minimal bias in the prediction. So the graph below shows rainfall amount versus rainfall days, which is the blue one is original values and the orange one is predicted values. So the model captures the overall trend, but there are some noticeable discrepancies, especially during higher rainfall period. So for conclusion, we can see that the proposed model provides superior accuracy in predicting rainfall, minimizing bias and error. And the proposed model can be used in climate change assessment, agriculture planning, water resource management, and disaster risk reduction. For future research, further refinement of the model to improve prediction of extreme rainfall event and expand the model to the other regions is similar. All from me, thank you.
Thank you, Hamiza. So now we open the floor for any questions and for questions to the presenters.
Bismillahirrahmanirrahim. Assalamualaikum. My name is Mas Jamila. I'm from Institute of Engineering Mathematics from UNIMAP. I would like to ask Prof. Hafsha regarding your new method. If I'm not mistaken, your proposed, I think first step is centering the value is by minusing the median, right? I guess it is because the outliers. Is it correct?
Okay, I'm subtracting with median because median is less sensitive to the presence of outliers.
Okay.
Yeah, because if you, I mean, the existing method use mean.
Yeah.
Mean is very sensitive to the presence of outliers, so it will affect the whole steps.
Yeah. Okay. My second question will be on the, if I'm not mistaken, you are using the input for the PCA is using the covariance metric, right? If I'm not mistaken.
No, in the robust Mahalanobis distance,
You are using.
I'm using the location and the covariance matrix.
Okay.
Yeah.
Is there any reason why you don't use the correlation metric instead?
No, because for the robust Mahalanobis distance,
It
you have
will
to
be-
use the location and the covariance metric.
Okay. So means that if it is based on the location, covariance, it will be the best to represent the.
No, actually, you have to use the location and the covariance matrix.
Uh-huh.
Where for the existing methods,
Mhm.
I mean, we always call it classical methods.
Yeah.
They use the classic. They don't use robust method
Yeah.
to estimate the the location covariance matrix. So in this situation, it will affect the result of the detection of high leverage point.
Okay.
Because it is very sensitive to outliers.
Yeah. Okay.
Yeah.
Thank you very much.
All right.
Very interesting.
Hi, my name is Ho. Feel compelled to ask questions because I'm on the jury. So, Prof, I was wondering, right, in the SCAL data set that you use, did your team investigate whether the variables are exhibiting non-linearity?
Which data set?
In your paper, you mentioned there was a SCAL measurement thingy.
Oh yeah, that the data I get it from Dr. Noli. Nisi Melaya ada tak Dr. Noli here? Yeah, yeah, yeah. She gave me the data and
Did your team assess the nature, whether the data is exhibiting non-linearity?
oh, I did not check that. Yeah, but actually we have another paper where using support vector regression. In that using that support vector regression to detect high leverage point, we do not have. Doesn't matter any kind of distribution can have non-linear or not or linear or whatever distribution we have. But for this, I do not check. Yeah.
Yeah, because with PCA, when you have non-linear stuff, it penalizes.
Yeah, that's why we have another work where we use
Okay.
support vector regression.
Right, and I'm a data scientist by trade.
Yeah.
Just checking in did your team optimize for result by tuning the various parameters for PCA? Was there a consideration or
Yeah,
I just-
first we have to reduce the dimension because the dimension is very large. So we reduce the dimension to K component. Yeah.
Mm.
So after we reduce the dimension to K component, we try to use singular value decomposition to get the vector and so on, and then map back to the original data.
I see.
Yeah.
Right.
So it takes time. On that.
Right.
Yeah.
Prof, one last question. In your paper, you claim that there is time savings, but I saw in your result is dalam beberapa saat. Is that Does that scale? I mean, like, okay, granted that you're not using tremendous large data set to show.
That's not very scary. What I just want to tell here is that it's kind of cumbersome, to that method. I mean, the existing method, the last year that we published, where you have to reduce and then make back, and that's. I mean, for
That's a relative improvement.
yeah, right.
Okay, thanks, Prof.
Yeah.
Right. My next set of question, yeah. Sorry, yeah, I just feel compelled to ask. Miss So, right?
Oh, not me.
Yeah, yeah, Prof. A lot of questions. Thank you very much for interesting book, by the way, Prof. I mean, so I was wondering, right, when you were preparing for this paper, did you compare, when you set out to investigate the problem, right, did you look at econometric literature that checks for the interplay of things like inflation with the interest rate, with the treasury yield, stuff like that? I mean, yeah, never mind. You answer me first, then I'll answer my own leading question.
Thank you. Do you mean do the literature review?
Yes. Did you mean in formulating your problem, right? You wanted to see different interplay between different variables. So did you consider what was reported in the econometric fields concerning this kind of interaction?
Actually, no. I just
You let the data do the talking for you, is that right? All right. Yeah. So yeah, sometimes I think your work was okay. It proved known facts about the interplay between these kind of things. So sometimes, sometimes as a young statistician, we look at the data, we jump right into it, and then you forget that perhaps that may have been addressed. But nonetheless, very well executed investigation. Thank you, Ms. So my last question to Ms. Hamiza. Right. So your hidden Markov model, basically you used it to address the problem that the rainfall had too many zeros. Betul?
Yes.
Did you consider other way of like changing the distribution so that it's a bit normal? What was the motivation for the HMM actually? Why non-hidden Markov model versus don't know whatever other technique lah?
Based on as we discussed with my supervisor, NHMM is one of the best method that can cater excess zero in the data.
Yes, but did you consider that there are other methods that could have done the same thing? Any ablative studies to compare?
Yes.
Kenapa and none, and why hidden Markov model and not something else, for example? Okay, never mind. In future, kalau you have not thought of that in your problem design, maybe need to consider that lah. They'll help you come up with a study that's a bit more rigorous lah. Thank you very much. Well done.
Thank you.
I'll take one question from the online. Good afternoon all. I am Tan from Utah. I would like to ask the third presenter how to determine which atmospheric variables you include into the models. Atmospheric variables you include into the models. How to determine? Hello?
All right.
So the question is how to determine which atmospheric variables you include into the models.
The atmospheric data that we use also from 2008 to 2018. We use since that we use. Can I explain in Dui language? Sebab kalau dalam daily rainfall data, kita orang pakai yang mesti daily rainfall data dengan atmospheric data mesti selari, which is from 2008 to 2018.
So Tan, I hope she has already answered your questions. Any follow-up questions from you? Maybe you can just type on the chat mode. Yeah. Any questions from the floor?
I have a question for the second presenter. In your step, the first step, I see that you have mentioned that you clean the data, right? The first step. How do you clean the data?
I just remove the missing value and the outlier.
How do you detect outlier? Because it's very important. Yeah? I mean, you need to use a good methods of identification of outlier. If you just simply use the existing method, perhaps it will. I mean, you cannot clean all of the data because some of the existing methods have a swamping effect. Yeah, swamping and masking effect. In the data, what methods used to detect the outliers? But there are so many methods.
I sudah
Yeah?
lupa. I gonna ask Studio that I type the code. Dia sudah clean semua.
I can tell you. The thing about multi-quality, about your data just now, you get the value of VIF, which is very small, right? And you conclude that there is no multi-quality. But I just want to share with the audience some important findings that we have discovered. Yeah, the high leverage point, yeah, outlying observation in the X direction is another prime source of multi-quality that we call it high leverage quality influential observation that can be classified into high leverage quality reducing and enhancing observation, where a high leverage quality reducing observation is that in the presence of high leverage point, it cannot show that the values of VIF is large. Yeah. So that you will get misleading. Just want to share with you. If you have any problem, you can ask me.
Lot of questions from Tan. For the dimension of the atmospheric data, longitude and latitude you use? Yes, from the questions that he had just now.
No, we don't use longitude and latitude.
Another follow-up questions. There's a lot of atmospheric variables such as sea level, pressure, temperature, and etc. How do you choose which one include into the model?
We use for atmospheric variable, we use humidities, solar, maximum temperature, minimum temperature, and lagi satu, and rainfall, precipitation. I mean.
No more follow-up questions.
All right, thank you.
All right. Any more questions from the floor before we stop the session? None? All right, thanks to the presenters. Then I'll just hand over the session to the MC.
Us to express our deepest gratitude to the moderator and all of the presenters. Moderator and presenters are requested to take seats below for the next session. As a token of gratitude and appreciation, we invite Yang Bersha, Mr. Muhammad Sofi Ali, Director of Malaysia Statistical Training Institute,